remember, you need to answer in terms of two atoms only. Bonding is referring to intramolecular. So you need to look at the atom. I always say the A should guide you and say that it's between two atoms. Okay, because the A should kind of guide you towards atoms. So it's between two atoms only. What types of bonding can you remember did we have last year? Yeah. I'm hearing it. Covalent, ionic, and? So the first question you need to ask yourself when you get a question is it asking me about bonding or forces? If it's asking you about bonding, bonds are broken. Bonds get broken. Forces, you overcome. So please remember the difference in the wording there. Covalent, how do you decide whether something is a covalent? Two nonmetals. So it's going to be one nonmetal and another nonmetal. And how does this bond form? Sharing electrons. So there's going to be a sharing of one or two or three pairs of electrons. So it's always going to be, and you'll see that's part of the definition, it's a sharing of electrons between two nonmetal atoms. Don't say molecules, it's atoms. If you use the wrong words here, you do not get the marks. But you don't get a mark for just saying that it's covalent. You need to say which type of covalent. So we want three words. Remember last year I was hammering on the fact, the people that were with me, that you have to have three words. I want to know, is it a polar covalent bond, or is it a, what's the other one? Non-polar. What's the other name for non-polar? A non-polar or a pure covalent bond. We need all three words. You're going to see that these count 2 marks. So if you don't say polar covalent bond, if you just say polar or just covalent, you're only going to get 1 mark for that answer. How do you know, how do you decide here whether it's polar or non-polar? Say it, Kutsu. That thing, the electronegativity. You look at the difference in electronegativity, yes.
Now, can you say either non-polar or pure?
Yeah, it's fine. Okay, so change in electronegativity, the difference in electronegativity, sorry. So if the difference in electronegativity is 0, which one is it? Okay, so here the difference in electronegativity is 0. So that means there's an even, please use the right words, even sharing of electrons, not distribution, even sharing of electrons. But here, you need, so that is just, you need to ask about electronegativity. Here the difference in electronegativity is not equal to 0. You don't have to do it on a scale. IEB made it easy for you. It's either 0 or it's not. If it's not 0, then you know it's an uneven. What's the word I should use? Uneven sharing of electrons, which causes it to be a polar covalent bond. This has nothing to do with the molecule. Please remember that. It doesn't tell us the polarity of the molecule. But the product that forms, what are these particles called that we form when the sharing has now taken place? We form molecules. And these bonds, guys, are actually the strongest. The sharing bond is very strong. Okay, you share it, it's like getting married, sharing your life forever. No divorces are allowed to happen in covalent bonds. Okay, sharing. So that's a very strong bond, not a force, bond. Yeah. Now, for ionic, what happens, how do you know that it's ionic? It's going to be a metal. Ooh, that's a very ugly M. It's going to be between a metal and a non-metal atom again. Remember, we only look at 2 atoms. So what's going to happen? What's a metal going to do? It's going to transfer an electron, or 2 or 3. But it's an electron transfer, which means that the metal has now got a lack of electrons. So what charge does it have? Positive charge. And the non-metal, a negative charge. So I form a cation and an anion. Oh, I should actually show them separately first. And now what does a negative and a positive do with each other? Attract each other. What do we call this force? No, I see it's coming back to you. Electrostatic force between the positive and the negative ion. And that gives me a crystal. What's the word? Yeah, guys, look at you. You remember everything. Crystal lattice. Can the ionic substance conduct electricity in this solid form? No. Bad conductor. Actually, cannot conduct. Guys, this is in your books, but obviously not on one page. So it cannot conduct. Why not? What force is keeping them stuck there? The electrostatic forces. Many of them. Remember, they work in 3 dimensions. Many. So use the word many electrostatic forces. Many. They want the word. Many electrostatic forces. So the ions are not free to move. So ions cannot move. The word move, we said the other day, is important. How can I get them to conduct? This one we actually did just the other day. How can I get an ionic substance to conduct? There's 2 ways. I need to make it an aqueous or a liquid. Because then, in both of these forms, the ions are free to move and conduct. Okay, so here to get aqueous, you're going to dissolve, and some people also did remind us that this dissolving is actually the dissociation of ions, or you can melt them. And that's all you need to know about an ionic substance. These forces are pretty strong, but it's not a bond we're breaking. It's a force that we overcome. What are the particles still called? Ions. Still cations and anions. And then we had metallic bonding, which is a metal and a metal. Please remember, metals are very densely packed. So when you have your positive nucleus, so in your book they call them positive kernels, positive ions. I don't like that word, positive kernels. I would rather say use positive nuclei, because it's not an ion really, because the electron's not moving for you don't form an ion. So it's a it's a positive nucleus, but then what happens is, because they're so densely packed, remember these outside energy levels or orbitals, they start overlapping. And therefore you've got little valence electron over there that doesn't know if it belongs to this nucleus or that nucleus, because it is, what's the word? It's in the electron cloud, and they are free to move, which means we call them, what do you call the electrons? C of, what's that word I'm looking for? Delocalized electrons. Yes, so it forms a C of delocalized electrons. And that is why a metal can always conduct electricity. What are the particles that move here to conduct the electricity? C of delocalized electrons. It is all in your book, just not on one page, Donnie. You can go and look for it there. Okay. So guys, a bond is always going to be stronger than an intermolecular force. Please remember this. The bond is always wins above an intermolecular force. But which of these three can have intermolecular forces? Only covalent, because covalent is the only one that forms molecules. And therefore only covalent can take us over to intermolecular forces, which is the next bit we need to crash course. Just one thing we need to mention here is you've got two different types of covalent molecules. You can have simple covalent molecules, which is like your CO2, I2, H2O. Those are all simple molecular structures. And then you've got three that has to scream at you as well as North screams at you. Yeah, you've got three giants. Those three giants, you actually need to spot them from a mile away because they always have the strongest forces, strongest bonds, I should say. But they are going to have the highest melting and boiling points. What are the three you have to look out for?
Silicon dioxide.
Yes, diamond. Please look out for diamond. It's that structure that carries on, and the whole thing is just one big mush of carbon atoms. The whole thing is a molecule. So when you want to melt a diamond, you need to break bonds. So diamond, and then we've got graphite. Graphite forms the layers, remember, of carbons. Layer of carbons. Inside the layer, the bonds are strong, but between the layers, there are weak intermolecular forces. That's why your pencil can glide off onto your page. Do you remember this? Okay, and then the last one is silicon dioxide. That's glass. And it looks very similar to the diamond, but you're going to see that you've got then just different types of atoms. You've got SIs and you've got O's. There are pictures of all three of these in your books. So go and look at the diagrams in your books.